All right, here we go, part 2. Now it looks like we're looking at multiplying polynomials. And then we'll be doing, other things. But it's a little more difficult, but still I think as long as you're careful and you kind of remember how things go, basically, then you should be fine. So all right, let's look at the first problem here. You got a minus 7, okay, gotcha. Guess that's a binomial, times a plus 4, that's a second binomial. So we could use, if you want, it doesn't really matter what you call it, I guess, but I think we talked about the FOIL method. Whenever you have a binomial times a binomial, you can kind of remember that you're multiplying first times first, outer times outer, inner times inner, and then last times last. Or, to me it's even easier, is just like, I kind of just focus on one term of the first binomial, like a, let's say. Okay, I'm focusing on a. I'm going to distribute him onto both of the terms in the second binomial. So first I'll do a times a, that's a squared. A times 4 is 4a. And then once you're done with the first term, I kind of forget about that guy and focus on the second term. It's a negative 7. Yeah, don't forget it's not just a 7, it's a negative 7. So he's multiplied by both terms in the second binomial. Negative 7 times a is negative 7a. Negative 7 times 4 is negative 28. And if you just do it that way, it amounts to the same thing as FOIL. First, outer, inner, last. So I don't know. I don't really even do FOIL in my head. I usually just do that. I just do focus on one term, multiply that by every term in the second polynomial. Once that's done, now focus on the next term, and etc., etc. I don't know. It just seems more simple. So okay, a squared doesn't have a like term, but the two middle terms, 4a minus 7a, those combine to make negative 3a. And then the last guy doesn't have a like term, so he just stays as is. And that's it. Let's see, this next one should be similar. It might be, I don't know, I guess because there's a power on the m, it might be a little more confusing, but that's okay. So I'll do the same thing. I'm going to look at the first term of the first binomial. We got 3m squared. I'm going to distribute him onto this 3m squared and the 4. So first it's 3m squared times 3m squared. That's 9m. And remember, m squared times m squared, if you're multiplying a variable times a variable, you add the powers. So it'll be m to the 2 plus 2, is 4. And then we had 3m times the 4 over here, that's 12m squared. Alright, now we've exhausted everything for the first term. We'll forget about him and we'll focus on the second term, negative 4, and he'll be multiplied by both terms in the second polynomial. Negative 4 times 3m squared is negative 12m squared. Negative 4 times 4 is negative 16. Alright, and similar to the last one, the first term has no like term, and neither does the last term. The two middle ones are like terms, but they actually cancel, because 12 minus 12 is 0. So you really just end up with the first term and the last term. And that's about it. It actually makes sense. If you've kind of ventured into the factoring sections at this point, you should recognize this guy as it started. I kind of butchered how it started, but it kind of looks like a difference of squares. You notice that? It's as if someone had the difference of squares and you factored it out. Because notice you have the same term, 3m squared, 4 and 4, but opposite signs in the middle, a minus and a plus. That's how you factor a difference of squares. So if you've seen the factoring stuff, you've probably seen us go from the answer to the beginning. Anyway, the next one, this one's probably kind of designed to, I don't know if it's like if you're not paying attention or you kind of forgot how this works, you might try to distribute the square, but remember, if you have something inside parentheses and then to a power, you can only distribute the power if everything inside the parentheses is either being multiplied or divided. As soon as you see a plus or a minus inside the parentheses, you cannot distribute the power. So because there's a minus in the middle here, I cannot, I wish I could, that'd make it easier, but I can't distribute the power, unfortunately. So I have no choice. All I can do is think about what does it really mean to square something or raise something to the second power. It means to take this thing that we're raising to the second power and multiply it by itself. So this really means 6 minus 5x times 6 minus 5x. And then I'll multiply it out like we did in the previous problem. I'll focus on the first term here, 6. Multiply it by each term in the second polynomial. 6 times 6 first is 36. 6 times negative 5x is negative 30x. All right, and then I'll focus on the second term. Think of it as negative 5x, not just 5x. So negative 5x times 6 would be negative 30x. And then negative 5x times negative 5x is positive 25x squared. Because it was an x times an x. And you add the powers. 1 plus 1 is 2. We got some like terms in the middle. We combine those guys to make negative 60x. But other than those, there are no other like terms. But I guess we should write this in descending order of powers. 25x squared, sorry, negative 25x squared minus 60x plus 36. There we go. Beautiful. All right, let's see about the next one. This one's kind of getting more complicated because you notice it's not a binomial times a binomial, it's a trinomial in the second polynomial. So when I focus on one term, like the 2x, I'll not only be multiplying it by 2 terms over here, I'll be multiplying it by 3 terms. So first we have 2x times 4x squared, that's 8x to the third. 2x times negative x is negative 2x squared. 2x times 7 is 14x. And now I'll focus on the second term in the first polynomial, the 1. 1 times 4x squared will be 4x squared. 1 times negative x is negative x. 1 times 7 would be 7. All right, let me scan here. I see 8x to the third does not have a like term, but the negative 2x squared and the 4x squared can combine to make positive 2x squared. Next we have a 14x and a negative x, that's 13x. The last term, the 7, has no like terms, so I'll just bring him down. There we go. Okay, next one. This one's even more complicated because the last one had 2 terms and then 3 terms. Now we have 3 terms and 3 terms. But it's still the same kind of procedure. I'm going to focus on the first term of the first polynomial and multiply it by every term of the second polynomial. So first we have y to the 4th times y to the 3rd. You add the powers to get y to the 7th. And then y to the 4th times y. If I add those powers, 4 plus 1 is 5, so y to the 5th. And then y to the 4th times negative 1 will be negative y to the 4th. All right, now I'm going to move on to the next term. That guy's done for. Now think of this next term as negative 2y times the first term in the second polynomial times the second term times the third term. We got negative 2y times y cubed. That's negative 2. If I add the powers, y to the 1 plus 3 is 4. Negative 2y times positive y is negative 2y squared if you add the powers. Negative 2y times negative 1 is positive 2y. Okay, so that's that one. Last term in the first polynomial. Okay, that means we're almost done. We're going to multiply that 3 times each of the 3 terms in the second polynomial. 3 times y cubed, excuse me, 3y cubed. 3 times y would just be 3y. And then 3 times negative 1 will be negative 3. There we go, okay. Whew. If I scan through all these terms, the highest power is the 7th power. And there's no like term for him, so he's just going to kind of be brought down. Same for the y to the 5th. He has no like term either. But then once I get to the next highest power, the 4th, I think there are a couple of y to the 4ths. So you have negative 1 minus 2, that's negative 3y to the 4th. The next highest, next highest power is this 3y to the 3rd. After that, there's only one y squared here, huh? Okay, so we'll just bring that guy down. Negative 2y squared. And then what do we have? 2y and 3y makes 5y. And the last guy is the constant term, which has no like term. So we'll just bring him down. Whew, that's quite the answer, huh? Wow. All right, it's easy to make some silly mistake on that. So I'd say if this was on an exam and you were multiplying this out, I might do it twice because it doesn't take very long. I mean, be careful and go slow on both tries, but just to make sure you did it right. If you get the same answer twice, that's probably a good sign. Okay, what about the next one? All right, and this one, you notice in the previous video we said, man, it seems like we're adding a lot of polynomials. What's the difference? It's like, oh my gosh, here's another one. But in this section, I think this is the first time where we've seen polynomials with multiple variables. Yeah, in the previous sections, we were adding and subtracting terms, but we never saw an x and a y in the same polynomial, that kind of thing. But it's the same idea. And this one, I can just remove the parentheses outright because there's nothing to distribute. And then same thing with the second one. I mean, I guess I can say I'm going to distribute the plus, but what's that going to do? It's just going to keep everything the same. All right, now I look around and make sure, if you're trying to combine like terms, they have to have the exact same variable or variables and the exact same powers on those same variables. So, for example, the 6x squared and the 5x squared, those are like terms because they only have an x and no y, and they have the same power on x. And of course, 6 and 5 makes 11. So got those down. And you have negative 2xy minus 8xy. Those are like terms, and if you combine their coefficients, you get negative 10xy. And the last terms are like terms as well. The y squared minus 2y squared, that's like 1 minus 2, that's a negative 1, or a negative y squared. There we go. Yeah, and that one you could have put negative 1y squared, but it's not quite simplified, so you'd want to take the extra step of removing the 1 just to write it as y squared. And the thing about these problems is, since we have two variables, there's no such thing as this descending order of powers now. So don't worry, I just say, it doesn't really matter what order they're in, actually. If you had these three terms in any order, I couldn't mark you wrong, as long as you have the right sign with the right term. But yeah, there's no such thing as what we were talking about before, descending order of powers when we have two variables. Because if you tried to put it in descending order of powers, I mean, what would go first, the 11x squared or the y squared? You know, they both have the same power, so what's going from largest to smallest? And even then, what about the xy? X has a 1 power, y has a 1 power. So if you put those together, that's like a second power. So it's really almost like all three terms in your answer have the same power. So I would have no idea what order to put them in. So yeah, it doesn't really matter in these. If you only have one variable, it's clear what order to put them in, descending order. But yeah, if you have more than one variable, it just doesn't really matter what order. As long as you have the right coefficients and the right signs on the correct terms, don't worry about the ordering. Alright, next one we have subtraction, so I better be careful. When I remove parentheses, I better distribute this minus sign onto every term in the second parentheses. But the first parentheses aren't really there for any reason. I'm just going to get rid of them. 2r squared t minus 5rt plus rt squared. Okay, this, if I distribute the minus, it'll be a minus 7 r squared t, a minus rt, but then that subtraction sign and this subtraction side would make the 5rt squared positive. Alright, let's see, and be careful because you notice, for example, this guy, you got 2r squared t and rt squared. Those have the same variables, r and t, and kind of like the same powers. I see a second power and a 1 power, and same thing here, but they're on the wrong variables. This guy, r, has a second power. Here, t has a second power. So they're not really like terms. You have to have not only the same variables and the same powers, but the same powers on the right variables. So those are not like terms, but I do see r squared t here and a r squared t here. Those are like terms. 2 minus 7 is negative 5 r squared t. And what are the like terms? Here I have a minus 5rt. Here's another rt way over here. So minus 5rt minus rt, that's negative 6rt. And the last two terms that are left over are like terms. Positive rt squared plus 5rt squared. That's like 1 plus 5 is 6rt squared. There we go. Beautiful. And that might look weird and you might think, oh, should I rearrange that? Yeah, if you want to rearrange it, that's fine. Just doesn't really matter. Yeah, there's not really a right order and a wrong order when you have two variables, or more than two variables. Alright, and the same thing will happen here. We're going to multiply everything out, and it won't really matter what order we put everything in the end. But I'll try to be similar to the previous ones where we were multiplying. Focus on one term, 3xy, multiply it by both terms in the second polynomial. See, we got 3xy times 4xy. Well, first of all, 3 times 4 is 12, and then the x times the x makes x squared, and the y times the y makes y squared. You can kind of think of it like that, as kind of separate pieces. And now I'm multiplying 3xy times 2. That's just really 6xy. And now I'm going to focus on the second term, a negative 1. He's multiplied by both terms in the second parentheses. Negative 1 times 4xy will be negative 4xy. Negative 1 times 2 will be negative 2. Alright, it looks like the two middle terms are like terms. But the first guy has no like term, so he'll stay as is. And the last guy has no like term. But the 6xy minus 4xy, that makes 2xy. I guess that one, it looks like it's in descending order of powers. So some of them, I guess it's clear what descending order of powers is. Because you got x squared, x to the 1. Here, y squared, y to the 1. So it is descending. We got kind of lucky, I guess, that happened. Ooh, this one looks like a doozy. The next one. But let's try it. So same kind of thing. I'm going to just take the first term of the first polynomial, 2xy, multiply it by each term in the second polynomial. So we have first a 2xy times a xy. That's 2. We got x times x, that's x squared. Y times y is y squared. And next we're multiplying 2xy by y squared. That's really not going to change the 2 or the x. It's just going to add more to the y. You had a y to the 1 power. Now you're adding a second power. That makes 3. 1 from the original term plus 2 more that you're giving to it. Alright, we've kind of taken care of the first term. He's done. Now let's focus on the second term. X squared y is multiplied by xy and then y squared. So we're really just adding the powers. X squared y times xy. If I add the powers of x, I get 3. If I add the powers of y, I get 2. Now if I look at x squared y times y squared, x squared has nothing to combine with, but the y times the y squared, if I add the powers, I get y to the 3rd. Alright, then the last term in the first polynomial is the 3. I'm going to multiply the 3 by the xy and then by the y squared. That's pretty easy. 3 times xy is 3xy. 3 times y squared is 3y squared. Easy peasy. And if I glance through this, I don't think there are a lot of like terms here, huh? Let me just look at the first guy. It's got 2x squared y squared. Do I see any more x squared y squareds? Nope. Remember, they have to have the exact same powers on the exact same variables. So even though, for example, this guy down here, it has an x squared, but it doesn't have a y squared, it has a y to the 3rd, so it's not a like term. How about the next guy? 2xy to the 3rd. Is there another xy to the 3rd? Nope. Okay then. How about the next term? X to the 3rd y squared. I don't see anybody that looks like that. Okay. I guess I don't know why I'm rewriting it, because I don't think there are any like terms here, huh? Yeah, and then everybody else has no like term. So I'm not really sure why I'm rewriting it, because it's exactly what I wrote above, but oh well. This is definitely an example of one where I would have no idea what descending order of powers means. I mean, are you talking about x descending order of powers, y, both put together? Whatever. Just write it in whatever order you want, and yeah, as long as the right coefficients and the right signs are with the correct terms, you're fine. Ooh, now we got long division. This is where it gets complicated. I guess this is where we kind of pay the price for adding and subtracting polynomials was really easy, as long as you're careful. Multiplying polynomials, it was pretty good, as long as you're careful. Dividing is the doozy, so I guess it's like the little sacrifice we make. Okay, remember, the one you're dividing by, x plus 5 in this example, goes outside the division bar, and the one you're dividing into goes inside the division bar. And if you remember, you want to look at your divisor and your dividend, both of these, the one outside, the one inside. If there are any missing terms from the first to the last, you have to put a 0 there. But in the divisor, we have a 1 power and kind of like a 0 power here, because it's a constant. So there's nothing in between the 1 power and the 0 power. The inner polynomial, the dividend, you're not missing anything either. I have a square, x to the 1, and then the constant term. But I guess let's just say, what if it was just x squared minus 15? There was no 2x. Well, then you have a squared term, but you don't have an x term. You're kind of missing a term in between the x squared and the 15. So you'd have to put a 0x in your division bar. So we'll see one like that coming up. I just wanted to mention it so it doesn't come as a shock when we get there. Okay, now that we've set it up, it's very overwhelming, but what we want to do is just focus on the first term, this x and this x squared, and then just say, okay, what's x divided into x squared? Or an easier way to think of it, what would I have to multiply x by to get x squared? Well, x times x is x squared, so that would be our quotient kind of for that one. And then once you find the quotient, you multiply that quotient by however many terms there are in your divisor. Every single term outside the division bar gets multiplied by the quotient, and whatever you get goes beneath. So first I have x times x, that's x squared. X times 5 is 5x. All right, now I got to be careful because I subtract, but I got to remember that the subtraction sign is meant for the entire thing I just wrote. So I'm going to put it in parentheses and think of it distributing inside here. So it's like this x squared becomes negative, as does this 5x. And then I'll combine vertically. X squared and negative 5x cancels. 2x minus 5x is negative 3x when I combine these guys. And then the next step would be bring down the next term, the minus 15. And then you start the cycle over again. I ask myself, what would I have to multiply x by to get negative 3x? X times what is negative 3x? That'd be negative 3. And now that I have that piece of the quotient, I'm going to take that negative 3 and multiply it by each term outside the divisor. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. Okay, now I'll subtract those guys. And I know we're almost done because there's nothing left to bring down, so this must be the last cycle we're looking at. And be careful because the subtraction sign is meant for everybody, so it makes this minus sign a plus, and it makes this minus sign a plus once you distribute. Negative 3x and 3x is 0. Negative 15 and 15 is also 0. So you have no remainder. And remember, you're supposed to write your answer as what? It's the quotient plus remainder over divisor. And the quotient is always what you found above the division bar, right? The x minus 3 in our case. So that's our answer. X minus 3 plus, we got a remainder of 0 over the divisor was x plus 5. But you know, whenever your remainder is 0, you might as well not even write it. So our answer is really just x minus 3. Yeah, because think about a fraction of 0 over something. That's 0 divided by something. 0 divided by anything is 0, so this is nothing. Yeah, so if you get a 0 remainder, there's not really even a reason to write it. It's only if it was something other than 0 that I'd write it in my answer. That way our answer is just x minus 3, nice and simple. How about the next guy? This one looks sort of like the last one, because it's 2 terms divided into 3 terms, I guess. All right, let's try this one. So we're dividing x minus 2, that's the divisor, into 3x squared minus 2x minus 13. And neither of these polynomials has any missing terms. The middle one I've got x squared, x, constant. Outer one I've got x to the 1, constant. All right, nothing missing. I'm just going to start dividing. Focus on the first terms. X times what would be 3? Yeah, x times what would be 3x squared? We would need 3x. X times 3x would make 3x squared. So I'll take that guy and multiply it by both terms outside. 3x times x makes 3x squared. 3x times negative 2 makes negative 6x. And now I got to subtract, but I better be careful because that subtraction sign is meant for everyone in here. So I'll distribute. This subtraction sign makes this 3x squared negative. The subtraction sign makes this negative a positive. And now we're just combining vertically. Negative 3x squared minus 3x squared is 0. They cancel. Negative 2x plus 6x makes 4x. Let me bring down the last term. So we must be on the last cycle because I'm bringing down the last term. And I'll ask myself, okay, how does x, the guy outside, divide into 4x? Or in other words, x times what is 4x? It would be 4, a positive 4. All right, now I'll multiply that 4 by both of the terms in the divisor, 4 times x and then 4 times negative 2. So 4 times x, that makes 4x. 4 times negative 2 makes negative 8. And it's easy because we're almost done. I almost want to rush it, but be careful because that subtraction sign, now we're subtracting. It's meant for everyone. So he gets to go to the 4x, making 4x negative. He gets to go to the 8x, making 8x positive. And then combine vertically. 4x minus 4x is nothing. Negative 13 plus 8 is negative 5. So that must be our remainder. And remember, like we wrote on the other side, the answer is quotient plus remainder over divisor. Our quotient was 3x plus 4 plus the remainder we just found, negative 5 over the divisor is x minus 2. If you wanted to, though, you could have written that as 3x plus 4, and then instead of kind of like a plus a negative like we have, you could just put minus 5 over x minus 2. I guess that's kind of like you bringing the negative that was on the 5 to the side of the fraction instead of leaving it at the top. But I'd say either of these is fine. I don't know if one's better than the other. They're both good. Okay. Next one. This next one, I can already tell there's a missing term on the top. So I'm going to think of this right away before I even start setting up the division. This is t squared. There's no t to the 1 power, so I'm going to have to write out 0 t to the 1 power. There's a missing term there. So remember, from the highest power to the lowest power, 2 to 0, I need every in-between power. So I was missing the 1 power. That means I need to put a 0 there, or else the division won't really work out. But the divisor t minus 4 is good because it has a 1 power and as a constant 0 power. So it's not really missing anything from the first to the last. Alright, now I think I can set up the division. T minus 4 is being divided into t squared plus 0t minus 13. So again, we'll focus on the first terms there. T times what is t squared? That would be t. Now let me multiply the t by both terms outside. T times t would be t squared. T times negative 4 is negative 4t. But now I need to subtract, and I better put the subtraction in parentheses and distribute the minus sign. Minus on the t squared, minus on the negative 4 actually makes it a positive 4. And now I can combine vertically. It's a t squared minus t squared, that's nothing. 0t plus 4t is positive 4t. Let me bring down the next guy, minus 13. Alright, since we're bringing down the last term, I know I'm almost done. This must be the last cycle. I want to say t times what is 4t? Well, t times 4 would be 4t. And now I'm going to divide the 4 that I just wrote as part of the quotient by both terms in the divisor. 4 times t, and then 4 times negative 4. 4 times t is 4t. 4 times negative 4 is negative 16. And now I'll try to subtract those guys. That minus is going to distribute to make this 4t negative and make this 16 positive. And if I combine vertically, 4t minus 4t is nothing. But 13 and positive 16, negative 13 plus 16 is 3. That must be our remainder there. The quotient is t plus 4 plus the remainder is 3 over the divisor is t minus 4. Beautiful. Alright, this next one, I can tell it might have some missing terms, but first of all, all the terms are in the wrong order, you know? I think problems like this, they're why we always put things in descending order of powers. So first thing I'm going to do probably is write the numerator in descending order of powers. The highest power is 6w to the 4th. And then I'd be searching next for the next lowest power. After a 4th power, you should see a 3rd power, but I don't see one, so I'm going to put a 0, because I know that would be a missing term that I need to fill in. 4th power, 3rd power, there is a 2nd power, negative 3w squared. There is a 1 power as well. The very first term was a w to the 1, so I'll just take that guy. And then there was a constant term of 4. So now I have all the in-between powers, I guess. 4, 3, 2, 1, nothing. The denominator, the highest power is the 2nd power, 2w squared. I don't see a w to the 1. I should see the next lowest power, w to the 1, but I don't see one. So I better insert my own, 0w. And then the constant term has a 0 power, so he's fine. So just setting this one up is tricky because it's missing a term in the numerator and the denominator. Alright, but now I know what the divisor goes outside, 2w squared plus 0w plus 1. And the dividend, the numerator, goes in the fraction bar, or the division bar. 6w to the 4th plus 0w to the 3rd minus 3w squared plus w minus 4. Okay. So be careful. Yeah, it's not only, they have to have all the in-between terms. If they're missing them, you have to kind of insert your own 0w to the whatever. But not only that, it has to be in the right order. You have to have them in descending order of powers. But once you set it up, then the idea is the same from there. Look at the very leftmost term of the divisor and the dividend, and ask yourself, what would you have to multiply that guy by? 2w squared times what is 6w to the fourth? Well, first of all, 2 times 3 would be 6. And then w squared times what is w to the fourth? It'd be another w squared. Because I need the 2 more w's to make the 4. Alright, now that I have the quotient, I'm going to multiply it by every term in the divisor. I guess there were 2, but I put 3 there because I had to add the 0w. So I got 3w squared times 2w to the third. That'll be 3w squared times 2w squared is 6w to the fourth. And then 3w squared times 0w, 3 times 0 is 0. W times w squared is w to the third. And then 3w squared times 1 is 3w squared. And if you're thinking, okay, the middle term, that's 0w to the third. But 0 times anything is 0, so why even write it? Well, it's really kind of a placeholder so that you have like terms above each other. That's kind of really it. We know that's really a 0 there, but it's just kind of nice to see the w to the third, just so we know that our like terms are lined up vertically. Alright, now we need to subtract, but again, you have to put everything in parentheses and then distribute that subtraction sign onto everybody. So 6w to the fourth becomes negative, the 0w to the third becomes a negative, as does the 3w to the second. And then you can kind of forget about the subtraction inside. You've distributed, so you're done. Now we'll combine vertically. 6w to the fourth and negative 6w to the fourth is nothing. 0w to the third minus 0w to the third, that's still 0. W to the third, that's 0. So those are gone as well. Last thing is negative 3w squared minus 3w squared now, because we distributed the minus, remember? So it's like a negative 3 minus 3, that's negative 6w squared. Okay, we're good. Now let me bring down the next term, plus w. Okay, yeah. And I think we're going to have to eventually bring down this 4 as well in the same step, but I might not notice that right away, so I'm going to pretend like I don't know that. I'm bringing down the w and I'm going to continue from there. Now I'm trying to divide, or ask myself, 2w squared times what is negative 6w squared? Well, 2 times negative 3 is negative 6w. But then w squared is w squared, so I don't really need any w's. So the quotient there is just negative 3. I'm going to have to multiply that negative 3 by everyone outside in the divisor. Negative 3 times 2w squared, negative 3 times 0w, negative 3 times 1. So first I have negative 3 times 2w squared, that's negative 6w squared. And then negative 3 times 0w, that's still 0w, because 3 times 0 is 0. And then lastly there, negative 3 times 1 is negative 3. Alright, now I have to put a little subtraction sign. Subtract all these guys. Let me distribute that minus. It'll make this negative a positive. It'll make this positive in the middle a negative 0. And it'll make this negative at the end a positive. And now that I've distributed, I can just kind of forget about it. But now I'm realizing I'm missing a term because I'm trying to add that last guy 3 to what? There's nothing there. This is where I realize I probably should bring down another term at the same time. So there are problems where you might bring down one term and then you realize you need to bring down another term. So you should have as many terms on the top here as on the bottom. You should be adding and subtracting the same number of terms. Okay, let's go for it now. Negative 6w squared plus 6w squared is nothing. Positive w minus 0w is still positive w, because it's like 1 minus 0. That's still 1. And we have negative 4 plus 3, that's negative 1. Alright, now that there's nothing left to bring down, we must be done. And another way to know you're done, I guess, too, is the next thing I would do is try to divide 2w squared into w. But how are you going to do that? You can't divide w squared into w, it's too big. So you know you're done, and your answer is going to be the quotient 3w squared minus 3, the thing that we had above the division bar, plus our remainder was w minus 1 over our divisor, 2w squared. And this, since you're writing your answer, you're not doing anything with it, I don't really need the 0w. I'm just going to write plus 1. I only put the 0w there just to make the division easier. So you don't want it in your answer because it's redundant and unnecessary. We just added it to make our lives easier, that's all. Whew, so that's quite the answer right there, huh? Pretty complicated looking. Alright, I think we're doing pretty good. Division's kind of complicated. Now we'll move on to factoring. So this is reviewing all the factoring techniques. The first one, this section 5.1, is just factoring out the greatest common factor. That's it. So this first problem, part A, I'm looking at, I think for me, since I see numbers, you see 35, 10, and 15. You see variables A, you see variables B. I'd focus on one thing first, and then the next, and then the next. So the numbers, 35, 10, and 15. What can be divided into all those things? I think 5 is the only thing, right? And remember though, if your very first term is negative, you always want to take that sign out. That's kind of hard to remember. Yeah, that's always true. If your first term, and I hope you know what I mean, first term is the leftmost term on the left, is negative. You want to factor a negative out. It's hard to remember, but that's always true. It's usually positive, but in the rare cases where it's negative, you want to make sure that negative comes out as well. Alright, so 5 is the number that divides into all the coefficients. Now I look at the variables. So A, they all have an A in common, but how many can I take out? Remember, you look at all the powers of A. I see 3, 2, and 3. You have to take the smallest one. So between 3, 2, and 3, the smallest is 2. Because remember we kind of said, if I try to take 3 out, the middle term doesn't have 3 to spare, because I'm trying to take 3 A's from everybody, but the middle term doesn't have 3 A's, so how could I take it away? I really can only take 2 from everyone, not 3. For the B's, the powers are 4, 3, and 2. The smallest of those is 2. Okay, that must be our greatest common factor. And we'll have parentheses left over, and we'll have a space for each of the original terms. One for the first term, one for the second term here, and then one for the third term. And you just see, so the greatest common factor, or the greatest common factor outside times what would make the term you want. So, for example, negative 5a squared b squared times what would give me the first term. You can kind of do it step by step. Negative 5 times what is negative 35. It'd be 7. A squared times what is a to the third. That'd be a. B squared times what is b to the fourth. That'd be b squared. Alright, and then same for the next term. Now I want to know negative 5a squared b squared times what is 10a squared b cubed. Well, negative 5 times what would be 10, would be negative 2. I need a negative times a negative to make the positive. A squared times what is a squared? Well, we already have a squared. I don't need any more a's. B squared times what is b to the third? I need one more b there. Alright, and then lastly, negative 5a squared b squared times what would make negative 15a cubed b squared. So let's see, first of all, negative 5 times what is negative 15? Be positive 3. A squared times what is a to the third? A. B squared times what is b squared? Well, that's already perfect, so I don't need to do anything. So there it is. Negative 5a squared b squared outside. 7ab squared minus 2b plus 3a inside. There it is. And if these ones easy to check, all you have to do is distribute. So try to go backwards to check. What if I multiply this by this, and then this, and then this? Do I get what I started with? If you don't get what you started with, you either factored the GCF out wrong, or you multiplied wrong when you checked. One or the other is going on, so you better be careful. Alright, now we're looking at part B. I want to do something similar, and I think this one might be easier because there's only one variable, but we'll see. There are 4 terms, so that might make it harder. But I'm going to focus on the numbers here. We got 24, 20, 28, and 4. I think the greatest common factor of those guys is 4. The largest number that divides in is 4. And they all have an x in common, so I know I can take some number of x's out. But remember, I can only take the smallest degree I see. I see powers of 5, 4, 3, and 2. The smallest is 2. That's really all I can take out there. And then inside the parentheses, I need a space for each of the original terms. There was 1, 2, 3, and then 4. So I'll need 4 terms inside. Yeah. So let's focus on the first guy. My greatest common factor, 4x squared times what would make 24x to the 5th. 4 times 6 is 24. X squared times what is x to the 5th. Another way to think of it is just how many more x's would I need to get from 2 to 5? I would need 3. And then the next term, 4x squared times what would make negative 20 x to the 4th. Well, negative 5 times 4 would make the negative 20. I need 2 more x's to get 4 x's. And now 4x squared times what makes positive 28x to the 3rd. 4 times 7 is 28, and I would need 1 more x to get x to the 3rd. Lastly, 4x squared times what is negative 4x squared? Well, 4 times what is negative 4? That's negative 1. X squared times what is x squared? Well, you already have all the x's you need, and that's it. There's your answer. 4x squared outside, 6x to the 3rd minus 5x squared plus 7x minus 1 inside. And to check, yeah, it's really easy to check. You can even do it in your head. Just imagine just distributing this 4x squared inside onto all 4 terms. As long as you get what you started with in this problem, then you must have done it right. Alright, good. What about the next guy here? So factor by grouping. This one, I mean, you don't use it as often, so it's easy to forget. But remember, factor by grouping, you only use it when there are 4 terms. So that'll be good to know, because this problem, they tell us to factor by grouping, but there will be problems coming up where they'll just say factor and we won't know what method to use. But again, when there are 4 terms, you know you want to use factor by grouping. So I'm going to draw a little kind of line between the second and third term, because you want to group the first 2 together and group the second 2 together. So I'm going to look at just the first 2, kind of ignore the second and the third. You can even kind of cross them out or put your finger over them for a second if you want. Just say, what's the greatest common factor between these 2 terms? 2x to the 3rd, 12x squared. It'll be 2x squared. Because 2 is the largest number that divides into both coefficients, and then x squared is the smallest exponent. Let's see, then 2x squared times what makes 2x cubed in x? 2x squared times what makes negative 12x squared, negative 6. Alright, now that we've taken care of that, now I want to go and look at the 3rd and the 4th term and try to do the same thing with those guys. And now I'm ignoring the 1st and the 2nd term. So say between negative x and 6, what's the largest thing that divides into both? Well, nothing really divides into both, but the kind of the cheap, I guess the cheap way to go is 1 divides into anything, so that must be the greatest common factor, 1. But if you remember, it's hard to remember this, but when you factor by grouping, whatever the very middle sign is, you have to have that in the middle as well. So I'm not only factoring a 1 out, I have to factor a negative 1 out, because the sign above it was a negative. And then I'll say, okay, negative 1 times what is that term, the first term we had there. Negative 1 times what makes negative x? That would just be an x. And then negative 1 times what makes positive 6? I would need a negative 6. Negative 1 times negative 6 makes the positive 6. Okay, now you're thinking of this left thing as one big term, and the right thing as one big term. And what's their greatest common factor, or what do they have in common? Well, they have that x minus 6 in parentheses in common. So that's their greatest common factor. And then the leftovers go in the second parentheses, this 2x squared, and then this minus 1. There we go. And then remember, when you factor, it doesn't matter what order your factors are in. So if you had written the 2x squared on the left and the x minus 6 on the right, that's the same. As long as you have the same things in parentheses, it doesn't matter which parentheses comes first. It's not wrong or right. Yeah, what order they're in. Okay. So the next section, this is where you have a trinomial with no number in front of the first term. So notice y squared here in this problem, there's no coefficient other than 1. So that makes it easy. Actually, these guys are all very easy problems. You just go, all right, this is going to factor into something, something, variable, variable. You just need to figure out what are the 2 numbers that multiply to this and add up to this. So what multiplies to 8 but adds to 9, that would be 8 and 1, or 1 and 8, either way. Because 8 times 1 is 8, 8 plus 1 is 9. So there it is, that's it. Easy peasy. Or of course, like we said, if you had written it backwards, y plus 1, y plus 8, that's the same thing. As long as you have the same factors, it doesn't matter what order they're in at all. So the next one, we're going to try to do something similar. It's going to be an x, or whatever your variable is. And then what multiplies to the constant term, but adds up to the middle coefficient? What multiplies to 12, positive 12, but adds up to -7? You have to think about that. It would be -4 and -3. Because -4 times -3 is 12. -4 plus -3 is -7. Or again, you could have written it backwards, x minus 3 and then x minus 4. As long as you keep the same sign with the right number, then you're going to be fine. Either one works. Okay, this next guy, this one is a reminder that once we're kind of set loose on factoring, where they just say, okay, factor this, and they don't tell us what method to use, the first thing you should always think of is, well, let's see, let me write this down. When factoring, your first thought should always be, is there a greatest common factor? No matter what method you're using, that might make your life easier. Is there a GCF? Yeah. And in this problem, there is a GCF. I think 3 divides into all 3 of these numbers. So if I factor a 3 out, what's left over might be easier to factor. Let's see, 3 times what is 3p squared? That'd be p squared. 3 times what is -9p? That'd be -3p. 3 times what is -84? Let's see, 3 into 84... Let me see. Sometimes it's hard to remember. 3, 28. Okay, -28. Gotcha. Okay. And now what's inside the parentheses, I should be able to factor that like we did the previous problem. But I'm kind of, this 3 is just along for the ride. Let's see, so it's going to be p and p. And then what multiplies to -28 but adds up to -3? That would be -7 and +4. Or the other way around, +4, -7. So you could write your answer like that, or the p plus 4 first, and then the p minus 7. It doesn't really matter. Yeah, those are both fine. As long as you don't forget to put the 3 outside, because he's part of the answer for sure. Alright, good stuff. And the next one, let's see, is there a greatest common factor between these 3 terms? Yes. They all have an a in common. I can take out the smallest number of a's I see. The smallest number is 2. But remember what we said about if the very first term is negative, you want to also take a negative out. So don't forget that guy. Now I have to figure out what's inside. -a squared times what is -a to the 4th? That'd be +a squared. -a squared times what is -6a cubed? That'd be +6a. And lastly, -a squared times what is +16a squared? That'd be -16. No need for an a because I already have all the a's I need. And if you want, you can do a quick little mental check by distributing this a squared back in to make sure you get what you started with. Alright, now it should be that what's inside factors further. Let me just carry this -a squared along. It's going to be an a and an a. Then I need to figure out what multiplies to -16 but adds up to 6. It'd be +8, -2. Or vice versa. It could be -2 plus 8. As long as you keep the right sign with the right number, it doesn't matter which one comes first. But that works, yeah, because +8 times -2 is -16. +8 plus -2 is +6. Notice though, if you'd written, instead of a plus 8, a minus 2, a minus 8, a plus 2, would that work? That would not work, because although -8 times 2 is -16, -8 plus 2 is -6, but we want it to be +6. So really the right sign on the right number does matter, because if you switch the signs, it won't add up to the right thing. It's supposed to add up to a +6, but ours would have added up to a -6. So be really careful on the signs. It's easy to kind of overlook the signs and think they're not that important. Okay, let's see, where are we now? The next section. Okay, these ones are a lot more difficult. So this section was where you have a trinomial, kind of like in the last one, but you have a number in front of x squared. It's not just going to be something x squared, something, something. It's going to be, yeah, you have a 6 there. Also, this problem here has a GCF. The coefficients 6, 10, and 4 have a 2 in common. I'm going to factor 2 out. That might make my life a little easier. Let's see, if I take 2 out, 3x squared minus 5x minus 2 is left. Okay. So I think when we went over the section, we said, okay, there are a few methods on how to do this, but I think my favorite way, it'll always be right. You won't have to guess and check, but it takes a little while. So what we did, we said you have to go make this little diagram here, figure out what a times c is, where you're thinking of this coefficient, this is ax squared, this is bx, this is c. So a is 3 and c is -2. 3 times -2 is -6. You want to multiply those together, and then just whatever b is, the middle coefficient goes down here. So -5. So again, it's the outer two numbers. The 3 times the -2 goes in the top of this little diagram, and then the middle coefficient, -5, goes in the bottom. And what you're looking for now is what two numbers multiply to the top number you wrote, but add up to the bottom number. So what multiplies to -6 but adds up to -5? That would be -6 and +1. Because -6 times +1 is -6 like we want, but -6 plus 1 is -5. Okay, now that we know those two numbers, the next thing to do, I'm going to leave this 2 outside and focus, and then kind of, focus on what's inside here. You're going to rewrite the trinomial you have in the middle, 3x squared, but where the middle term was, it was -5x. I'm going to split it into 2 terms. Each of them have the same variable, where the coefficients are the numbers you just found. I found -6 and +1, so I'll have a -6 on one of them and a +1 on the other. Remember that, that guy splits up into the 2 numbers you want. And it almost seems like something you're not able to do, like, can I even do that? You can do that because think about if you were to simplify this. -6x plus 1x is -5x. So if I were to simplify what I just wrote, I would get what I had above. So all I really did was make it look more complicated, that's all. It's the same exact expression. But writing it this way allows us to factor by grouping. So remember, a little ways back in the section 5.1 problems, we were factoring by grouping. We have 3x squared minus 6x plus 1x minus 2. But remember, to factor by grouping, you're going to kind of split it right down the middle. The first 2 terms get together, the second terms get together. Let me see, I'm going to focus on, the first and the second term there, between the 3x squared and the 6x, what can I factor out of those guys? Their greatest common factor is a 3x. And if I factor 3x out, 3x times what is 3x squared? That'd be x. 3x times what is -6? That'd be -2. Okay, now I have to do the same thing for the third and the fourth term. Between 1x and -2, what's their greatest common factor? Well, nothing really, so that means a 1 is their greatest common factor. And then remember, whatever the sign is above it, you keep that going on. So it should be a +1 I'm factoring out. If the sign above was a negative, I'd also factor a negative out. Alright, now I say 1 times what is 1x? That'd be x. 1 times what is -2? -2. And now I think I'm doing something right, because this big term and this big term have this x minus 2 in common. So I'll factor that out, leaving that 2 outside, just kind of along for the ride. And then the leftovers go in the last parentheses. 3x was left over from the first big term, plus 1 was left over from the second big term. There we go. So this definitely takes some practice if you haven't seen this in a while. You know, if you did this section a while back and you say, oh man, I totally forgot this, I'd probably go back and try to practice some problems, because it just takes a lot of repetition to get good at these. Yeah, I think if you had all the steps in front of you, like someone wrote them out, of course, it might not be that bad, but it's trying to remember the steps and implement them that's kind of difficult. So let's try the same thing on the next problem. This one, though, at least it might be a little easier, because there is no common factor. 10y squared, -11y, and 3, they have nothing in common, so I'm just going to skip straight to making the little diagram thing here. So I'm looking for, remember, what's a times c? The first times the last. 10 times 3 is 30. What multiplies to that, but adds up to the middle number, -11? So I got to think about that. Okay, what multiplies to 30, but adds up to -11? If I ever get stuck, I just think 30 can be what? 1 times 30. Is there any way to get that to add up to -11? No matter which one I make a negative or positive? No. Too far apart. How about 2 times 15? No, they're too far apart as well. 3 times 10? Nope, too far apart. 4 doesn't go into 30. How about 5 times 6? Ah, those are the guys. Because if you make them both negative, there you go. Okay, -5, -6. because negative 5 times negative 6 is 30. Okay, check. Negative 5 plus negative 6 is negative 11. All right, good. We found them. Those are the guys. Negative 5, negative 6. Now we're going to rewrite the trinomial we were given. I'm going to rewrite the first and the last terms exactly the same, though. 10 y squared. I'm going to leave a little blank space, plus 3. So the first guy is the same, the last guy is the same. But the middle guy, negative 11y, is going to be split up into two terms. They're both going to have a y attached, but they're going to have coefficients that are the numbers we just found. The first number we found was negative 5. The second number we found was negative 6. So negative 11 split up into two. Yeah, negative 5 and negative 6. Now we're going to draw a line right down the middle and factor by grouping. Once we do that, we're done. I feel like at this point I'm home free. As long as you feel fairly confident about factor by grouping, you should be good from here. And keep in mind too, if at this point factor by grouping doesn't work, you probably found the wrong numbers here. They might seem like the right numbers, but there's something wrong about them. Maybe the signs don't work out or something like that. But let's see, if I factor by grouping, let me focus on the first and second terms. The greatest common factor between the first and second term is 5y. If I factor 5y out, what would be left? 5y times what is 10y squared? 2y. 5y times what is negative 5y? That'd be negative 1. Alright, so we got those two. What about the third and the fourth term? Between negative 6y and 3, the common factor would be 3. But I have to factor a negative out because there's a negative above it. Now negative 3 times what is negative 6y? That'd be 2y. Negative 3 times what is positive 3? That'd have to be a negative 1. Alright, good. Now I see, yeah, if at this point the things in the parentheses, the red part right there, are not the same, like ours we have 2y minus 1 on both of them. That means we're doing something right. But if for some reason they're not the same, that probably meant something went wrong, and it's usually these numbers are the wrong numbers. They might have seemed like the right numbers, but when you go back and consider it, it's probably not quite right. Okay, those two big terms have 2y minus 1 in common. The leftovers are 5y minus 3. That'll be it. Beautiful. And you can always check this by foiling it out. Multiply this out, 2y times 5y, that's 10y squared. 2y times negative 3 is negative 6y. Negative 1 times 5y is negative 5y. Negative 1 times negative 3 is positive 3. And these combine to make negative 11y. And that is exactly what we started with, so we must have factored it right. Alright, but the answer is what we boxed. That was just me checking to make sure I factored right. Alright, this next problem, notice they're trying to confuse me because they have the terms in the wrong order. I have to have it from highest power, 6m squared, to lowest power, 5m minus 30. Alright, now I'm going to check for greatest common factor. There is no greatest common factor here. Nothing divides into 6, 5, and 30. All at the same time. So I'm going to move on. Now I'm going to make my little diagram. I first have to multiply a times c. A is 6 and c is negative 30. Ooh. 6 times negative 30, that's negative 180. Oh man. Alright, that's pretty crazy. So I want to know what multiplies to that, but adds up to the middle guy, 5. This is a tricky one. I'm going to have to think about 180. Okay, this just seems like really silly, but if you really can't think of the two numbers, just start dividing, the number that you're trying to multiply to. Think about what divides into that. 180 divided by 1 is 180, but there's no way 1 and 180 are going to add up to 5. They're too far apart. Yeah, no matter which one you make, negative or positive. So how about 2 goes into 180 90 times? Those are way too far apart to ever add up to 5. Does 3 go into 180? Yes, 60 times. Those are still too far apart. How about 4? 4 into 180 is 45. Still too far apart. Does 5 go into 180? Yes, but I'm not sure how many times. Let me see. 36 times. Okay, those are still too far apart. 6 goes into, oh my gosh, everything goes into 180, huh? 6 goes into 180, I think 30 times, right? Yeah. Oh, still too far apart. Does 7 go into 180? No, finally, something does not divide in. Does 8? 8 does not go in. Does 9 go in? Yes. 9 goes in 20 times. Those are still too far apart. They're never going to add up to 5. 10 goes into 180 80 times. Or no, sorry, 18 times. Those are still just a little bit too far apart. Does 11 go into 180? No. How about 12? Does 12 go into 180? Yes. 12 goes into 180. Oops. 15 times? Are those are still too far apart. Ah! Oh my gosh. I can't believe I just realized I wrote it down wrong, and that's what's going on. You guys are probably thinking, what the heck is she doing? It's 60m squared, not just 6m squared. Oh my gosh. No wonder this wasn't working out, huh? Oh my gosh, you're probably rolling your eyes at me right now. Hello. 60. Alright, now there is a greatest common factor. Oh my gosh, why am I such a dingling? 60, 5, and 30. 5 divide into all those. What a dingling I am. 5 times what is 60? That'd be 12m squared. 5 times what is 5m? That'd be m. And then 5 times -6 makes -30. Alright. Hello. I think that's nice. I mean, we still have to do the diagram thing, but at least the numbers are smaller. Oh, thank God. Oh, a times c. 12 times -6 is -72. Okay. So I want two numbers that multiply to that, but add up to the middle coefficient, which is a 1 here. So what multiplies to 72 but adds up to 1? Well, that one, since they have to add up to 1, I always think, okay, what multiplies to 72, but they're kind of two numbers that are only 1 apart. Well, I think of 9 and 8. They're only 1 apart. And since I want them to add up to a positive, I need to make the larger one positive and the smaller one negative. That way 9 plus -8 is positive 1. 9 times -8 is -72. Okay, good. So those are the guys. All right, good. So I rewrite the 5 outside. He's just kind of there to try to confuse us. I don't want to drop him, though, because my answer will be wrong. 12m squared stays the same. The -6 stays the same. But the middle term is going to split up into something m and something m. Two separate terms. They're the coefficients that we just found. We found 9, positive 9, and then -8. Now I'm going to split it right down the middle and factor by grouping. Okay. There's a 5 outside there. Now between the first and the second term, what's the largest thing that divides into 12m squared and 9m? It'd be 3m. Okay, 3m times what makes 12m squared? That would be 4m. 3m times what makes 9m? That'd be 3. Okay, now between -8m and -6, what divides in? -2. -2 times what is -8m? That'd be 4m. -2 times what is -6? That's +3. Alright, it looks good. The 4m plus 3 is the same on both, so that must be good. Carrying the 5 outside. The 4m plus 3 is what they have in common. I just need one more parentheses for the leftovers. We got 3m minus 2. Beautiful. Alright, sorry about the mix-up at the beginning. Come on. What was I thinking? Okay. Okay, this next one, I think I can tell that there's going to be a common factor here. So it looks like, I think 3, I was going to say 9, because 9 goes into 27 and 72, but not 48, right? No. Alright, well, 3 is something. 3 can come out, and then any variables? Yes. At least they all have an x in common. But I can only take one x out, because the smallest power I see is a 1. And they don't all have a y. The first term doesn't contain a y. Alright, but at least that's something. Maybe when 3x comes out, the rest will be easier to factor. If I take a 3x out, let's see, 9x squared minus 24xy plus 16y squared would be left. Alright, but then for what's left in the parentheses there, I'm going to have to do the same method that I've been doing. I just have to carry that 3x along as I go. I'll make that little table thing. I got A is 9, C is 16. A times C, let's see, what's that? 144. I want to know what multiplies to that, but adds up to the middle guy, -24. Actually, that's easy, right? First thing you think of, 144 is 12 times 12. But you want them to add up to a negative, so you want them both to be negative. Because a -12 times a -12 is positive 144. -12 plus -12 is -24. Whew. Good stuff. Okay. So we got 3x outside. I'm going to rewrite the first and the last term the same. 9x squared and then plus 16y squared. But the middle term is going to have, it has the same variables, xy, xy. You're just changing it to these coefficients here. So minus 12 and minus 12 are the numbers we want. So minus 12xy minus 12xy is what the middle term split up into. Okay, now I want to split it right down the middle and figure out what can I factor out of the first two terms, just still carrying that 3x in the front along as we go. Okay, between 9x squared and 12xy, 3x is what they have in common. Okay, 3x times what is 9x squared? It would be 3x. 3x times what is negative 12xy, negative 4y. Alright, now between the third and the fourth term, I can tell already I'm going to factor a negative out, because it's whatever sign is in the middle has to come out. What can divide into 12xy and 16y squared? I think 4y. Let's see, negative 4y times what would be negative 12xy, 3x. Negative 4y times what is positive 16y, negative 4y? Yeah. Alright. So those have the same thing in green. That's a good sign. If those weren't the same, again, I'd probably think I did something wrong, and it was probably the two numbers I found. So they have the 3x minus 4y in common. There's a 3x in the front just kind of following along. And then the leftovers are going to be what goes in the second parentheses here. Leftovers here are 3x. Here it's negative 4y. And that would be it, but now I kind of look at this carefully and I notice these are the same factor, 3x minus 4y twice. So they're going to want you to write it as that thing squared, 3x minus 4y squared. It just looks nicer that way, it's simpler. Good, okay. On to the next. I think we're looking at a new factoring method now. This section, it had a few tricks, but really the main takeaway from this section was difference of squares. If you remember, we had a little formula for it, which if you want you can write that on your little note card, or it's pretty easy to remember that something squared minus something squared, it factors into that thing, it's the same two terms, a and b, but with a minus and a plus. But notice, difference of squares, that means subtraction. Difference means subtraction. So if you see a plus like here, this is prime. It can't be factored if there's a plus. Only the ones with a minus, like this first problem, can be factored. And just like the little formula kind of shows, it factors into something minus something, something plus something. The first terms of both polynomials are, what are you squaring to get the first term? Well, that'd be z, because z squared is z squared. And then the second terms are, what are you squaring to get 9? That'd be 3, because 3 squared is 9. And there it is. And that, I can't write that as something to the power of 2, because those aren't really the same factor, because one has a plus and one has a minus. And we've already said the second one is prime because there's a plus in the middle. You can't factor a square plus another square. It has to be a square minus another square. This next problem, there's actually a common factor between them. If you're careful, I'm going to take a 2 out. Because 2 goes into 200 and 2x to the 4th. 2 times 100 is 200. 2 times negative x to the 4th is negative 2x to the 4th. Okay, now what's inside is definitely a difference of squares. So it's going to be kind of the setup like last time. Something minus something, something plus something. I'm going to bring that 2 down so I don't forget it. The first terms of both are, what can you square and get the first term? 100. 10, because 10 squared is 100. Second terms are, what can you square and get x to the 4th? X squared, because x squared to the second power is x to the 4th. And then sometimes at this point, one of these can be factored further. This guy kind of looks like a difference of squares, because it's something minus x squared. But you know what? 10 is not a square, right? 10, there's nothing you can write that squared makes 10. So that's all we can do. But you do want to check that. And this guy, since it has a plus, it has no hope of factoring anyways. Just like the previous problem, it's prime. Alright, but if that 10 were something else, like 16 or something, 16 is a square, so that would be able to be factored further. But as it is, I think we're good right there. Let's try this next one. 98w and 8w to the third. Okay, now I know for sure w can come out, right? Something w. And they're both even numbers, so 2 at least goes in. Does 4 go into 98? 4? No, I think that's it, huh? Alright. I think just 2w can be factored out. Oh well. It's better than nothing. What about if I take 2w out, what's left? 2 times what is 98? 49. 2 times what is 8? That'd be 4. And then w squared. And then I think what's left in the parentheses is a difference of squares, huh? So it's something minus something, something plus something. Alright, and those somethings are, first of all, what can you square and get 49? That'd be 7. So 7 is the first number in both parentheses. And then what can you square and get 4w squared? That'd be 2w. Because 2 squared is 4, w squared is w squared. So there's your answer. 2w times 7 minus 2w times 7 plus 2w. And these don't have to be in that order. These could be switched. Of course, yeah, as long as you have two things in parentheses, they can be switched and it doesn't matter. Because two things multiplying together, it doesn't matter what order they're in. Alright, this last one in this section, it looks kind of like there's something in common, but really they don't have anything in common. Because the first term has a p to the fourth, that's it. The second term has no p, so that's really all we can do. So I'm just kind of assuming this is going to be a difference of squares here. And I think it is, because p to the fourth, that's something squared. P squared, squared. And then 81 is 9 squared. Q to the fourth is q to the second squared. So I think, yeah, it's definitely going to be a difference of squares. So, okay, firstly, what can you square and get p to the fourth? Well, we already said p to the second. P to the second squared is p to the fourth. And then what can you square and get 81 q to the fourth? That'd be 9 for sure. And then q squared to get to q to the fourth. There it is. And now I want to just kind of scan to make sure that I can't factor any further. This guy has a plus. There's no hope of factoring that further because there's a plus. But I think this one's another difference of squares. Because the first term is something squared, p squared. The second term is also something squared because 9 is 3 squared. And q squared is q squared. So really this guy can be kind of broken down into two more factors. So kind of imagine him being the problem you were given. P squared minus 9q squared. It's going to be something minus something, something plus something. The first things in there are going to be, what can you square and get this first term? Well, of course, that's p. And then what can you square and get the second term? It'd be 3q. But since this other factor, this p squared plus 9q squared is prime, like we discussed before, because there's a plus in the middle that can't be factored, we'll just bring it down as is. So every piece to this can't be factored any further. There we go. Beautiful. Alright, that's a little tricky. Yeah, if you factor once, you might have to factor again. Be really careful on that one. Okay. Alright, now we're in the next section. So this is the last section of factoring techniques. After this, we'll just be kind of let loose on random factoring problems. But this was the difference of squares and the sum of, difference of cubes, sum of cubes. I'd say this is for sure, no doubt about it. I would put these little formulas on my little note card when I come to the midterm and the final. Because these are hard to remember. If you memorized them, that's good. Then you don't need to put them on there. But this is an invaluable piece because if you have the formulas, these are fairly easy as long as you're familiar with it. But if you don't have the formulas, it's kind of bad. So difference of dang it, I keep writing squares. I said cubes, hello. We did difference of squares in the last section, hello. Cubes, of course these are not second powers, these are third powers. Alright, so difference of cubes, that means you have a cube minus a cube. That guy would factor into a binomial times a trinomial. A minus b, a squared plus ab plus b squared. But if you have a sum of cubes, a cubed plus b cubed, yeah, remember, be careful, if they're squares, the sum of squares cannot be factored. But if they're cubes, the sum of cubes can be factored. It's almost the same as the last formula, but the first minus and the plus switch. So this plus went here, and this minus goes here, almost like. But almost the same formula. Yeah, for sure, I think if you had just a blank 3x5 card on the next midterm, I think that'd be okay as long as this is on there. This is probably the most important thing for me. Okay, so every problem that we're looking at now, we just have to determine which of these are we looking at. Difference of cubes or sum of cubes. Or the first one, we got x to the third minus 64. That must be the top one because it's a difference, the subtraction sign. Alright, so I'm just going to set it up and write kind of this skeleton here that I'm boxing by leaving the a's and the b's gone. This should factor into something minus something, something squared, plus something times something, plus something squared. That's how that formula looks if I leave the a's and the b's out, right? Alright, but in this case, now I just ask myself, what's a and b here? A is the thing you're cubing to get the first term. That would be x. B is the thing you're cubing to get the second term. What can you raise to the third power to get 64? That'd be 4. So I know 8 to the second power is 64, but we're looking for what to the third power. Because remember, the formula has a 3 as a power. So now you just fill it in. Fill the a's and the b's in. So remember, if you want the formula closer, our formula looked like a minus b, a squared plus ab plus b squared. So wherever there were a's, we're going to put an x. There was an a there, there's an a here, there's an a here. Wherever there are b's, we're going to put a 4. There was a b here, a b here. Oop, not a b, I said we're going to put a 4. Hello. And a b here. Alright, so it should be x minus 4. Okay, let me simplify. X squared plus, we have x times 4, that looks better as 4x. And then plus, the last guy is 4 squared is 16. There we go. Alright, it takes a little getting used to. It's kind of weird. But the more of these you practice, the better you'll get at them. So this next problem, there's a plus in the middle, so we'll be using the second formula there. This guy, a plus b, a squared minus ab. Yeah, because we're looking at this plus. So I'm going to kind of, maybe I'll write the formula below it so it makes it a little easier. It's supposed to be a plus b, a squared minus ab plus b squared. There we go. Okay. But I'm going to leave a and b out. It's going to be something plus something, something squared minus something times something plus something squared. Now I just have to determine what a and b are. A is the thing you're cubing to get the first term. That'd be 3, right? 3 cubed is 27. B is the thing you're cubing to get the second term. That'd be z, since z to the third is z to the third. But now I'll replace all the a's with 3. Here's an a. I'll put a 3 there. Here was an a. Here was an a. And all the b's with z. So here was a b, that's going to be a z. Here was a b, that's going to be a z. And here was a b, that's going to be a z. And as long as you fill everything in, it should be good. I'll just simplify. That's 3 plus z. Let's see, 3 squared is 9. Minus 3 times z is 3z plus z squared. And there we go. Beautiful. Alright, last one here, in this section anyway. Or no, almost the last one. I see that these two terms have something in common. They both have an a and they both have a b. So I think, well, they both have one a. How many b's can I take out? Well, the smaller power for the b's is 2. So that might make this a little easier. What if I take ab out, or ab squared? It'd be b to the third left plus 1,000. And no more ab's for that guy, because I took them all out. Now what's left in blue there, it looks like they're both cubes. B cubed, 1,000 is 10 to the third. Okay. Actually, this is kind of confusing, huh? Because the formula itself has a's and b's. Oh. Well, anyway. It's supposed to be, okay, since there's a plus, this is going to be the second formula up there, because that's the one with the plus. So I'll try to model this after this guy. I'm going to kind of write the formula a plus b, a squared minus ab plus b squared. B plus, there we go. And just don't forget your ab squared outside. Okay, this is kind of confusing, but a is supposed to be what you're cubing to get the first term. Well, that would be b. So where all the a's were in the formula, I'm going to put a b. There was an a here, there was an a here, and there was an a here. And then b from the formula is what you're cubing to get the second term, 1,000. But we already said 10 cubed is 1,000. So this was a b in the formula, this was a b, and this was a b. Okay, so if we simplify that, what do we have? ab squared in the front. B plus 10 can't really be simplified. B squared can't either. But minus b times 10 is 10b. 10 squared is 100. Alright, that looks good. Perfect. All right, this last one here. This one's a little easier, actually, I think. It's a difference of cubes because there's a minus in the middle. So I'll use the first formula, the top one, a minus b, a squared plus ab plus b squared. All right, so in this case, what's a? A is what you cube to get the first term, that's m. B is what you cube to get the second term, that's 1. So wherever the a's are here, I'm going to fill them in with m's, and wherever the b's are, I'm going to fill them in with 1's. So, okay, a was m, here was an a, here was an a, and here was an a. Here's a b, that's supposed to be a 1, this b is going to be a 1, and this b is going to be a 1. That's m minus 1, m squared plus, yeah, m times 1 is m, 1 squared is 1. That's it. That can't really be simplified. All right. So now we're kind of let loose on these problems. We don't have any idea of what to do. We just have to figure it out as we go. All right. But in this section, we had a step-by-step process on how to figure it out. The first thing we want to do, if I just focus on this very left problem here, you look at what you're given and say, is there a greatest common factor? First thing you should always ask. 98 and 18 do have a common factor of 2, that's it? Yeah, 2. That's kind of sad. 2 comes out, 49, t squared minus 9 is left. Okay, from there, what's left in the parentheses should look sort of similar to one of the types of problems we've seen, and this is definitely a difference of squares. So yeah, I'd say if you have it kind of stuck right now, you're saying, well, how do you know what method to use? I would look back at the steps we put in that section 5.6 in your notes. Yeah, so this is a difference of squares here. So the 2 is going to stay outside. It's a minus and a plus. What can you square and get 49t squared? That'd be 7t. What can you square and get 9? That'd be 3. There we go, and neither of those things in parentheses can factor further. That's really it. All right, next problem. There's another common factor, I think. For sure, at least all these 3 terms have an x in common. But also, I think 4 goes into all of them, right? Let's see. Yeah, 4 can divide into all those numbers. So the greatest common factor. Once we factor the greatest common factor out, I think what's left will be easier to factor. 5x squared minus x minus, oops. Let's see, 18? Yeah, okay. And now I look at what's inside. This is a trinomial. So it's either going to be the easy factoring method where it's just like an x and an x, what multiplies to this but adds to this, or it's going to be that complicated one with the little diagram we have to make. But seeing that there's a number in front of x squared, the 5, that makes it so we have to do it the complicated way, unfortunately. So I'm going to have to go, what's a times c? 5 times 18 is 90. Just want to know what multiplies to that, but adds up to the middle term, -1. Okay. So what do we got? 90. Actually, 90 is 10 times 9. If I want to add up to -1, I need the larger to be negative. So -10, +9. That would do it. All right. I'm going to rewrite what I have. 4x outside. The first term stays the same, 5x squared. The last term stays the same, 18. It's the middle term that splits up into something x and something x, where those somethings are the coefficients you just found, that -10 over there in the diagram and the +9. And then I'll factor by grouping. The 4x outside is still there. All right, between the first and the second term, 5x squared and -10x, they have a 5x in common. If I factor 5x out, what's left? X minus 2. Now between the third and the fourth term, 9x and 18, they have a 9 in common. That's a +9 because the sign above it is positive. There's a positive here, so I'm going to take a positive out. 9 times x is 9x. 9 times -2 is -18. That's a good sign they have x minus 2 in common, so that can be factored out. The 4x is still out in the front. And then the leftovers there, 5x plus 9, go in the last parentheses. Beautiful. Okay. I think the next problem, this one also has a common factor. A lot of these do, huh? And since I see there's a negative in front of the very leading term, I want to take the negative out. They all have an x in common. I can take the smallest number of x's I see. That's three of them. Okay, negative x to the third times what is negative x to the fifth? That'd be x squared. Negative x to the third times positive 14x would be negative 14x to the fourth. Negative x to the third times positive 49 would be negative 49x to the third. Okay, now I have a trinomial left over inside these parentheses, so it looks sort of like the last problem, but you notice there's no coefficient of x squared. Like in the last one, there was a 5 in front of x squared, which made it complicated. But since there's nothing in front of x squared, this is going to be an easy method. You could use the same method we just saw in the last problem, but it's overkill. I just need to put an x and an x, figure out what multiplies to 49 and adds up to 14, and I'm done. Well, that'd be 7 and 7. They multiply to 49 and add to 14. And since I see the same factor twice, I'm going to write that as that guy squared. There we go. Perfect. Alright, next one. These have a common factor as well. Hello. Every single problem has a common factor. 4 goes into 4x to the fourth and 64. See, 4 times x to the fourth is the first term. 4 times 16 is 64. And now when I look in what's in parentheses, there's two terms, and it looks like a difference of squares to me. X to the fourth is something squared, and so is 16. It's not a difference of cubes, because this is not something cubed, and 16 is not a number cubed, so that's it. Alright, but what can you square and get x to the fourth? That's the question. That'd be x to the second power, because x to the second power squared is x to the fourth. And then what can you square and get 16? That'd be 4. But one of these pieces is an extra difference of squares, because that's something squared minus something squared. So this guy can factor further. This one cannot, because remember, sum of squares is not factorable. That's prime. So now whatever my answer looks like, it's going to have this 4 in the front and this x squared plus 4, because that can't be factored. But I think this guy factors into another difference of squares, where the first terms are going to be, what can you square and get x squared? Well, of course, x. What can you square and get 4? That'd be 2. Whew, that was a doozy. Okay. And what else? We got a few more here just to mix it up. So this guy down here, this looks kind of unlike any of the ones we've seen so far in this section. But remember what we said when we did the problems from section 5.1, we said if you have 4 terms, that means you use factor by grouping. So that's the good thing. It's hard to remember because you don't use it very often, but if you do remember that if you have 4 terms, you factor by grouping, that's going to make your life a lot easier. So I'm going to split this right down the middle here. And between the first and the second term, I can factor an x out. If I factor x out, what's left there? That would be x minus 1. Between the third and the fourth term, what can I factor out? They both have a y in common, but I want to factor that sign that was above it out, so I'm going to take a negative y out. Negative y times what is negative xy? That'd be x. Negative y times what is positive y? Negative 1. So those both have x minus 1 in common. The leftovers are in green, x minus y. Beautiful. Okay, next guy here. Alright, look at this guy and I say, alright, it's got 3 terms. So it's either going to be that easy factoring method where it's just like w and w, what multiplies to this but adds to this. But unfortunately it's not the easy method because there's a number in front of the w to the fourth. You have the leading term, the one with the highest power, has a coefficient other than 1, like this guy has a 10. It's going to be that complicated diagram method with this box, or whatever, diamond shape here, I don't know. And I guess I should have said, I did scan for a greatest common factor first. These 3 terms have nothing in common. I mean, all 3 of them at the same time. I'm going to have to do that AC method. What's A times C? 10 times negative 6 is negative 60. What multiplies to that but adds up to the middle guy, negative 11. Let's see. Negative 60, what adds up to 11? That's a good one. Let's see, 60 could be what times what? 1 times 60, but those are way too far apart to ever add up to negative 11, no matter which one I make a negative or positive. 2 times 30, same thing. 3 times 20, same thing. About 4 times 15, that's a winner. Because 4 and negative 15 add up to negative 11. And 4 times negative 15 multiplies to negative 60. All right, good. All right, I think that sounds good. Let's rewrite what we had to begin with. 10w to the fourth, and the last term is negative 6. But remember, the middle term, the middle term is going to be same variable, w squared. It's going to be split up into two terms whose coefficients are the numbers we found. So the first number we found was positive 4, the second one was negative 15. All right, now we're going to factor by grouping, and once we do that, we should be good to go. Between the first two terms, 10w to the fourth and 4w squared, they both have a 2w squared in common. Okay. If I factor that out, what's left there? 5w squared. And then 2. Yeah, because 2w squared times 5w squared is 10w to the fourth. 2w squared times 2 is 4w squared. Between the third and fourth terms, I know first of all I have to take a negative out. So that's one thing, because there's a negative above it. But between 15w squared and 6, I think 3 is all I can factor out. So let's see, negative 3 times what is negative 15w squared, 5w squared. Negative 3 times what is negative 6, that'd be 2. Alright, it's a good sign, they have the same thing in common, 5w squared plus 2. And then the leftovers go in the second parentheses, 2w squared minus 3. And at first, one of these maybe kind of looks like a difference of squares, because I see the square on the w. Remember, just the fact that this is a plus means it's out of the running. That would be a sum of squares, if it's even a squares. That can't be factored any further, so I know he can't be factored further. This guy, I was thinking maybe difference of squares, since there's a minus, but 2 is not a square, and neither is 3. So really, that's all I can do. I should kind of check just to be safe, you know, think about it, but neither of those can be factored further, so that's it. This guy looks like, okay, there's two terms. When there's two terms, let's see, if you kind of forgot, that means it's going to be either difference of squares, but this is definitely not difference of squares because there's not a minus, there's a plus. Difference of cubes, the same kind of thing, difference means minus, there's not a minus, or sum of cubes. These are the only hopes you have of factoring, and this does look like actually a sum of cubes. See, the sum of cubes formula is, if you have something cubed plus something cubed, factors into the first thing plus the second thing, first thing squared minus first times second plus second squared. We just have to determine what's our a, what's our b. What can we cube and get 8t to the third? That'd be 2t. So a must be 2t. B is what you can cube to get the second term, 1. Well, that'd be 1. Alright, I'm going to take this formula, replace the a's with 2t and the b's with 1. A is 2t, okay, this was an a, here was an a. Be careful though, if your a or your b has two separate parts to it, like 2t, I would insert it in parentheses like this, because it's not just the t that's being squared, it's also the 2. So just to be safe, this was an a. Alright, then where all the b's were, I'm going to put that 1. Here was a b. Here was a b, and here was a b. Alright. 2t plus 1. See, then 2t squared. 2 squared is 4. T squared is t squared. Minus 2t times 1 is 2t. Plus 1 squared is 1. And that's it. Beautiful. Okay. So now on to actually using factoring to solve equations. So if you remember this section, what we're using is this zero product rule or zero product principle. I forget what they call it. But all it's saying is really if you have two things multiplying to make 0, like that. So if something times something equals 0, like we actually have in this problem, this thing in parentheses times this other thing in parentheses is equaling 0. That means one of them has to be 0. Either a is 0 or b is 0. Or both, I guess. They could both be 0. But really how that helps us is We can solve problems like this first one we're looking at here. As long as you have something times something equals 0, that's the key. It has to be 0 on the other side, then you can set each of those things equal to 0 and solve separately. So the first factor is equal to 0, the second factor is equal to 0. And if I solve each of those little tiny equations, that'll give me 2 solutions. So for the first one, if I want to solve for t, I'll add 8 to both sides. That'll give me 5t equals 8. So I've solved that for t, I'll be dividing by 5, and I'll get that t is 8/5. Okay. The second one, all I have to do is add 1 to the other side, and then t is found. Alright, we got 2 solutions, 8/5 and 1. Those are both solutions. You can just, if you want, you can just leave your answer like that. Just bam. Okay, next. In this next problem, we have a similar thing going on. X times x plus 4 equals 0. That means we can set each of the things being multiplied equal to 0. X is being multiplied by x plus 4. So they're each set equal to 0, and you have to solve each. Although x equals 0 is already kind of solved for you. I guess the solution is 0. But in the second one, I need to subtract 4. And I'll get -4. Alright, so the 2 solutions must be 0 and -4. Those are the winners. Alright, next problem, they're kind of taking the training wheels off. They're saying, hey, remember how the last 2 problems, we already factored them for you? Now you have to factor your own. So now I'm not able to just set anything equal to 0 yet. I have to factor first. Factor. So I want to make it look like those previous problems. This is a trinomial, and there's no number in front of a squared, so this should be the simple factoring method. What multiplies to -24 but adds to -5, -8, and +3. Okay, now I'll set each of those equal to 0. A minus 8 equals 0, a plus 3 equals 0. Okay, if I solve the first one, I'll be adding 8 to both sides, and I'll get a is 8. There's 1. To solve the second one, I'll subtract 3 from both sides, and I get a is -3. That must be our 2 solutions. Okay. Good. So for the next one, notice though that so far the first 3 problems we did, we had everything on the left side, 0 on the right side. And this one we don't. So we got to keep that in mind, that you want to get all terms on one side so that 0 is by itself, kind of like. So your first step should be get all terms on one side. And then factor, of course. And then set each factor equal to 0. That's kind of the procedure. We haven't had to do all those steps yet because they kind of helped us out a lot of times, but yeah, that's what we're going to have to do from here on out. So I think it'd be easiest to bring 25 to the left side. I'm going to subtract him. And remember we said you want your term with the highest exponent, the y to the second, to stay positive. If I were to move the 9y to the second to the right side, it would become negative and it'd be harder to factor. So I don't want to do that. But now that I have the 25 over on the left, I notice this is a difference of squares, because 9y squared is something squared, 25 is something squared, and there's a minus in the middle, which makes it a difference. So this will factor into something minus something, something plus something. First thing in the parentheses is what can you square and get 9y to the second? 3y. And then what goes in the second part of the parentheses is what can you square to get 25, and that would be 5. So now if I set each one of these equal to 0, I'll find the 2 solutions. This guy equals 0, and this guy equals 0. They look similar, but we're going to get opposite signed answers because they have opposite signs in the middle. To solve the first one, I'll add 5. Okay. And then I'll have to divide by 3. And that should do it. Y is 5/3. Alright. Sounds good. What about this guy? I'll subtract 5 from both sides first. Because there's a plus, I have to do the opposite and subtract. So 3y is -5. And then I'll divide by 3. Okay, divide by 3. Oops. So our second solution is the same but opposite sign. The 2 solutions, one's 5/3, one's -5/3. Cool, okay, good stuff. Alright, now this next one, it really helps to For sure, like we wrote the steps here, we want to get everything on one side. But there's a better side to get things on, and it's not always the left side, it depends. You want to look for the guy with the highest exponent, which is this guy. You say, alright, if his coefficient is positive where it is, you don't want to move it. But if it's negative like we have, we do want to move it. Because when I move him to the other side by adding, now it'll become positive, and that'll be easier to factor. So now I know which side to bring everything on. It must be the left side. So I want to make sure that the term with the highest power is positive. But I would have to also move this 2 over. Since the 2 is positive over there, I'll have to subtract it to move it. Now I have to write everything in descending order of powers. The highest power is the 12z squared. Then we have the minus 5z. And then the minus 2 that we moved over there. And 0 on the other side. Alright, and then the 3 terms I have, there's no common factor. So I can't factor anything out. And then the leading coefficient is not 1. It's something more complicated. So I'm going to have to do that complicated factoring method with the diagram thing. So I have to do, what's a times c? A is 12 and c is negative 2. 12 times negative 2 is negative 24. So you want to know what multiplies to negative 24 but adds up to the middle number. Let's see, what multiplies to negative 24 but adds up to negative 5, negative 8, and 3. Well, those are the guys, okay. I'm going to rewrite this. First term stays the same. The middle term is going to be split up into 2 terms with the z's. And then you have minus 2 stays the same. I'm going to keep the equals 0 as well. But those 2 numbers I found, the negative 8 and the 3, will become the coefficients of these guys. And then I'll split it down the middle. Alright, between the first and the second term, what can I factor out? They both have a 4z in common. If I factor 4z out, what's left there? 3z minus 2. 3z. Yeah, alright. And then what about between the third and the fourth terms? What do they have in common? 3z minus 2. They have nothing in common, but I have to factor something out, so it's a 1. And I have to factor the sign above it, positive 1. Don't forget your equals 0. So 1 times what is 3z? That'd be 3z. 1 times what is negative 2? Negative 2. They have the 3z minus 2 in common, so that'll come out. And then the leftovers will go in the second parentheses, 4z plus 1. Alright. Now we're pretty much there. I just have to set each of these factors equal to 0. Now that we have it as a product, something times something equals 0. Now I'm free to say, well, the first thing equals 0, or the second thing equals 0. Let me see, and I'll solve the first one by first adding 2. That'll give me 3z equals 2. And then lastly there, I'll divide by 3, and that'll give me my first solution. 2/3 it looks like, huh? Alright, there's one solution. The other guy, I'll have to solve by subtracting 1 first. And then 4z equals negative 1. And then the last step there would be to divide by the 4. There we go. And then z will be negative 1/4. Perfect. So our solutions are 2/3 and negative 1/4. Whew. Alright. Getting there. Alright, this last one in this section, I always hate these. It looks like they were being nice. You're like, oh, they factored it for us. But remember, it's only helpful if they factor it for us if there's nothing on the right side. It's almost like they forgot to include this 2 in their factoring. So them having the left side factored actually is not a good idea. I have to undo the factoring by multiplying it out. X times 5x is 5x squared. X times 4 is 4x. Negative 1 times 5x, negative 5x. Negative 1 times 4 is negative 4. Okay, so I'm going to now combine like terms. 5x squared. Let's see, 4x minus 5x is negative x. You know what, while I'm at it, I'm going to move this 2 over, because I know I need everything on one side. You have to get every term on one side and then factor. So I'm subtracting the 2 over, that'll make negative 6, because there was already a negative 4. Alright, now there's no common factor here. I'm going to have to do the same method I just did, that, unfortunately, that diamond method, because there's a number in front of x squared other than 1. A times c, 5 times negative 6 is negative 30. What multiplies to that but adds up to the middle coefficient of negative 1, that would be negative 6 and 5. because negative 6 times 5 is negative 30. Negative 6 plus 5 is negative 1. Let me rewrite this guy. First term exactly the same. Last term exactly the same. Middle term split up into 2 with those coefficients I just found. Negative 6 plus 5. And then I'll split it down the middle. Alright, between the first and the second term, what can I factor out? 5x squared and 6x have an x in common. If I take x out, what's left over? 5x minus 6. The third and the fourth term, 5x, negative 6 have nothing in common, but remember you have to factor something out, so I'll factor a 1 out. And there should be a positive 1 because there was a 1 above it. 1 times what is 5x? That'd be 5x. 1 times what is negative 6? That'd be negative 6. Alright, good sign. They have the same thing in common, 5x minus 6. Alright, and then the leftovers go in the second parentheses. I've got an x from the first term here, and a 1 from the second term. Okay, we almost have it. Now if I just set each of those factors equal to 0, should be good. 5x minus 6 equals 0. And then x plus 1 equals 0. Alright, to solve the first one, I'm going to start by adding 6 to the other side. That way I'll have 5x equals 6. And the last step there would be to divide by 5, and then we'll have one solution. X equals 6/5. Okay. So second one, have x minus 1 equals 0. To solve that guy, I'll have to add 1, or sorry, subtract 1 to the other side. Alright, there we go. There are two solutions. 6/5 and negative 1. Beautiful. Alright, now in the next section we're going to put all that to work, and we're actually going to use that to solve equations, or to solve problems. So we're going to have to set up our own equation and then solve it kind of probably similar to what we just learned in those previous problems. Alright, let's see. So this first problem here, the demonstration flower garden at a state fair is in the shape of a triangle. Alright. I already told you guys, I think. I like to draw a picture of it so I can label it. Doesn't really matter. Don't worry about, oh, look, my triangle has this side shorter than, I don't know. It doesn't matter. I just kind of drew it this way for no reason. But I guess what I'm thinking is they're talking about base and height, it looks like. So I'm thinking this is the height right here, how tall the triangle is, and then the base is how wide, I guess, kind of like. Okay, so what do they say? The base of the triangle is 6 meters longer than twice the height. Okay, so if you think about it, they're saying the base is, remember is code word for equals, 6 meters longer, so that's more, plus something plus 6 meters, than twice the height. Twice the height would be 2h. Okay, so if I wanted to, I can replace this b for base with just this expression, 2h plus 6. Hopefully that makes sense. 6 meters longer means plus 6, because that's more, longer. But 6 meters longer than not the height, but twice the height, which is 2 times the height. Okay, and then if the area is 28 meters squared, find the base and the height of the flower garden. And the most important part is they gave us this formula. And for sure, if you needed some kind of area or volume formula or something, it would be given to you for sure on the test. But you know what? I think if we fill in everything we know in this formula, we should be able to solve an equation. But remember, you can only solve an equation if you only have one variable. As it is now, we have 3 variables, a, b, and h. So we need to get everything to either become numbers or become all the same variable. So from left to right, the a for area, I can actually replace that because they told me the area is 28. That one is no problem. Now I'm one less variable here. 28, okay, equals 1/2, and I'm almost there. Now I have 2 variables left, a b and an h, but I need to only have 1 left. But what I can do is say, well, b, I found an expression for b over here. Oops. B is equal to 2h plus 6. I'm going to take b, kind of like with the substitution method, replace b with 2h plus 6. But the h at the end of the area formula stays the same, this guy. The base is 2h plus 6, which is how we labeled it over here, right? And now we finally have an equation that only has one variable. I only see h in numbers, which means we're actually able to solve it. If I still had 2 variables at this point, I'd have to figure out how to get one of them in terms of the other. But I think we're good now. Alright. So I have 28 equals 1/2 2h plus 6 times h. Okay, it's up to you now. You can either distribute this 1/2 into these parentheses, or you can multiply both sides by the least common denominator to get rid of that 1/2. And I think that's what I did when I did this problem. I said, you know what, I don't want to have to deal with that fraction, so the least common denominator here is 2. I'm just going to multiply both sides by 2, and that'll knock it out, because 2 times 1/2 is 1. On the left side, though, 28 times 2 is 56, right? Yeah. 2 times 1/2 is 1, so that's gone. All that's left is the 2h plus 6, and then the h on the right side. And sometimes I'm thinking, you know, I have to distribute the h on the right side, but we're used to distributing from the left side, so if you want, you can bring the h to the left side, if that feels more natural. You know, this guy, bring him over here. Excuse me, and then distribute the h. It does seem more natural, huh? Okay. So 56 on the left. H times 2h would be 2h squared. H times 6 would be 6h. Alright, now if I want to bring everything on one side, I don't want to move the 2h squared and the 6h to the left, because if I move the 2h squared, I'd have to subtract it. And that would make it negative. I don't want the highest power to be negative. I'm going to move the 56 over instead. That way 0 is all by itself. 2h squared plus 6h minus 56 is left. Okay. These three terms have a 2 in common. I can factor a 2 out. If I factor 2 out, h squared plus 3h minus 28 would be left. And then what's left in the parentheses there is this easy factoring method, because there's no number in front of h squared. I just have to figure out what multiplies to negative 28 but adds up to 3. About positive 7, negative 4, or vice versa. Negative 4, positive 7. Okay. Now that I have it all factored, like we saw in those the previous sections problems, we're going to set each factor equal to 0. The 2, the h plus 7, and the h minus 4, and try to solve each one for h. Although the first one, how is that ever going to happen? 2 equals 0, never. That's really not going to contribute anything. And I think we came across this when we went over the section in lecture, that if you ever have just a number with no variable, that's not going to contribute to the answer. So I didn't even really need to set that equal to 0. I could have ignored the 2. It's only the factors that contain a variable that really matter. So if we move the 7 over, h is negative 7, that's one solution. If I add 4 over here, looks like 4 is the other solution. But which one's right? Because this is talking about the height of a triangle. Well, you know what? Since this is a real-world situation, this is the height of a triangular flower garden. There's no such thing as a flower garden that's negative 7 meters long. Yeah, in real life, there's no negative height. I mean, in the math world, there are negative numbers, but in real life, I don't think that really works. Okay, that must mean that the height is 4 meters. Is that all they asked for, or do they want the base too? Yeah, they said find the base and the height. Okay, well, we found the height. The base isn't so bad, because remember, we had this little expression for the base. The base is 2h plus 6. And now that we know the height is 4, we just found it. I can just replace 4 here, and that'll tell me base. 2 times the height, which is 4, plus 6. That's 8 plus 6, which is 14. Alright. So should, you know how it goes, we should put this in a sentence since it's a word problem. The height of the garden is 4 meters and the base is 14 meters. You can abbreviate, especially units like meters. Don't feel bad about that. That's fine. Whew, it's tricky. Okay, let's try this one. Okay, this next problem. So picture, you know, in a book, if you have 2 pages, you know, let's say you open a book. The page on the left is, I don't know, like page 57, and the page on the right would be page 58, right? So they're always one apart if you're looking at 2 facing pages. So if I want to label these guys, I'm going to say, let's say X is the first page that I'm looking at. I mean, not like the first page of the book, but the first page that I'm looking at when I happen to open it. That would mean X plus 1 would be the second page, since it's just one more, you know, If you look at one page, you look at the next page, it's one further. Like for example, if you had page 57 and 58, those are one apart. You take the first number, you add 1 to get the second number. Okay, so just kind of so we know an algebraic expression for the page numbers, x for one and x plus 1 for the other. So the first sentence, it says, the product of the two facing page numbers is 420. The first thing I just got to remember is product means multiply, remember? It's something times something. But now that we have an expression for them, we have first page number, the product of that and the second page number. Okay, the word is, remember, is code word for equals 420. There we go, beautiful. So that's our equation we have to solve. X times x plus 1 is 420. Now this is one of those ones where at first I got all excited, like, oh, they factored it for us, that's so nice. But they didn't really factor it for us because they didn't involve this 420 in the factoring. So we actually have to undo the factoring by distributing. And then get everything on one side and refactor with the 420 included. Let me see, I'm going to move the 420 over. That way everything's on one side. This is a trinomial, but thankfully there's no number in front of x squared, so this is going to be that easy factoring method. You just want to know what numbers multiply to negative 420 but add up to 1. I think that would be 21 and 20. That might take a little while. Or 21 and negative 20. Might take a little while to think of, but yeah, 21 times 20 is 420. And 21 plus negative 20 is positive 1. Now I'll set each of those factors equal to 0. This guy and this guy. If I solve the left one, I'll subtract 21 from both sides to get x is negative 21. On the right one, I'll add 20 to both sides to get x is 20. But what did x stand for? We labeled x as the first page number. There should be only one right answer, and it's going to be the positive one, like in the last problem, because have you ever seen a book that had a page number negative 21? I don't think so. No negative page numbers. No way that's going to happen. So it must be 20 is the first page number. Then what would be the second page number? Well, you don't have to do a lot of math. It'd be just the next page would be 21. So there we go. The page numbers are 20 and 21. Okay. Alright, so the last one in this section, what do we have? These ones are actually better. I like these because they give us a little, not formula, but a little expression for it. For adults with certain heart conditions, the drug Primacor, I guess you would say, is prescribed. The number of milligrams of Primacor in the bloodstream of a 132-pound patient T hours after a 3 milligram dose has been injected into them is approximated by this formula. So it looks like they're saying M is what now? M was the number of milligrams in the bloodstream. Okay. We know that this M stands for the number of milligrams in the bloodstream. And they said T was time, but what was it measured in? Seconds or minutes or? T hours, okay. T is number of hours. Gotcha. Okay, so they want to know how long after an injection will there be 2 milligrams in the bloodstream. So really all I have to do is take 2 and know where to put that. But remember they said T is time and M is number of milligrams. So we're going to put a 2 here. Because that was the number of milligrams, not the T. And then we'll solve this equation. Now that there's only one variable left, T, we should be able to solve it. So let's see, I don't like fractions. And we know that if you're solving an equation with fractions, you can just multiply the whole thing by the LCD to get rid of the fractions. The LCD would be 2, so I'm going to multiply the entire equation by 2. And that should knock them out. So there was a 2 on this side, negative 1/2 t squared, plus 5/2 t over here. Let me distribute this 2 onto everyone. On the left, we got 2 times 2, that'll make 4. On the right, maybe I'll be careful. I'm going to write the 2 that I'm distributing and multiply it by the fraction. And then be careful, think about it. It's negative 1/2 t squared. And then I'm also distributing that 2 onto the second fraction. I'm going to write it out just to be careful. If you can see what cancels, you don't have to write this step, then that's fine. Just if you want to be really careful. So yeah, all I'm doing is writing the 2 next to this fraction as I distribute, and then write it next to this fraction. If I put each of those 2's over 1, I notice that the 2's canceled on the diagonal for both of them. So really it ends up kind of just being the numerators that are left. So this guy will just end up being negative 1t squared, or negative t squared. And this guy, since the 2's cancel, all that's left is 5t. That's pretty good. Alright, I need to get everything on one side and factor if I want to solve this. Since t squared is negative where it is, that's the leading term, I'd rather him be positive. I know if I move him to the other side, he'll become positive. So I'm going to move him, and that would mean his little friend is forced to move as well. Everything needs to move to one side. Alright, so we got t squared minus 5t, and then the plus 4 that was already there. 0 on the other side. I'll factor this guy. T and t, okay, and 0. Because this is a trinomial with no number in front of the t squared, so it can be the easy method. We just got to know what multiplies to 4 but adds up to negative 5. It'll be negative 4 and negative 1. And now I can set each factor equal to 0, and that should give it to me. Alright, if I solve the first one, I'll be adding 4 to both sides. So t equals 4 is one solution. To solve the second one, I'll add 1 to both sides. So 1 is the other solution. And actually, in this one, logic can't get rid of one of these, because I didn't get a negative answer. If I got a negative, that wouldn't make sense. You can't have a negative number of milligrams, or no, t is time, sorry. You can't have a negative number of hours. Now both of these make sense, actually. You can have 4 hours, you can have 1 hour. So it's actually 2 solutions. They were wondering, when will there be 2 milligrams of the drug in the bloodstream? That was the question. When will that happen? Well, that'll happen when, after 4 hours, because that's what t stood for, number of hours, and after 1 hour. That seems kind of weird, right? Why would it happen twice? I think because when you put blood into, or so you put this medicine into a patient's bloodstream, it kind of like the amount of drugs go up and then it comes back down like this. So after 1 hour, it hit the certain spot, and then it came back down, it hit it again at 4 hours, something like that. That's why, yeah, I think it peaked. I mean, you know, it went up and it came back down. So there were 2 times where it hit the specific number of milligrams. Alright, so pretty much we're on the last set of problems here. These ones you're going to simplify. So remember that it's very tempting, like in this first example, I want to cancel these m squareds and I want to cancel these m's. I want to say 4 goes into 8 twice and all that. But you are not allowed to do that. You can't cancel until you factor. These literally cannot be reduced right now. You cannot do that. So make sure, like this hint says, that you factor and then you can try to reduce. So these problems, just because this video is getting really long and we've already gone over all the factoring techniques, I'm just going to factor without explaining how to factor, because if you're at this stage in this midterm review and you don't know how to factor, I don't think you should have gone this far yet. You should go back and review the factoring more if you're not comfortable. So once you're good at factoring, then you can come back. I think that'll make more sense. For factoring the numerator, they have a 4m in common. Actually, I'm going to take a negative 4m out. What would be left? M minus 1. On the bottom, what do they have in common? Negative 4m, again. And then 2m minus 3 would be left. And then notice that, now that I've factored, I can reduce. Negative 4m cancel. What's left over is m minus 1 over 2m minus 3. And you cannot cancel those m's, because those m's are both part of their little factors. The m on the top is part of m minus 1, the m on the bottom is part of 2m minus 3. Okay. This next one, the top has a common factor of t, so I'll factor that out. And the bottom, you'd have to use this method with the something times something, 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 something. Let me see, what would it be? Okay, it'd be minus 3 plus 2 there. Once you're done with that method, right? And it looks like they have the t plus 1 in common. They have that factor on the top and the bottom. So the leftover factor on top is t. On the bottom is 2t minus 3. Okay. Next problem, the numerator is a difference of squares. If you factor it, it'll be 3z minus 4, 3z plus 4. The bottom one is another one of those where you have to do the factor tree thing. Let's see, it'll be 3z, okay, let me think here. It's going to be minus 4 and plus 2, right? Yeah, no. Oh no, whoops, sorry. There should just be a regular z right here. And be, oh, then I switched the signs, sorry. Should be a plus 4 here and a minus 2 there. Yeah, that'll do it. Okay. And now that I factored that, again, if you're thinking, wait, how the heck did that factor? You have to go and do that long method with the a times c is negative 24, b is negative 2, what multiplies to this, and rewrite it, factor by grouping. Just, I don't want this video to turn into a 3-hour video. So those cancel. What's left on the top is 3z minus 4, on the bottom z minus 2. Alright, we're getting there. Now the next ones, it's really, these ones are like a souped up version of those last problems. You know, since there's two kind of rational expressions next to each other, you have to factor everything. Instead of just factoring numerator and denominator, now there's 4 things to factor, each numerator and each denominator. The top, or the leftmost numerator, you factor a 12 out. The leftmost denominator, you factor a 5 out. Okay. On the left, or sorry, the rightmost numerator, you factor a 3 out. If you factor a 3 out, what's left is a difference of squares. The difference of squares will factor into y minus 5, y plus 5. So that, I wouldn't do that all in one step. You gotta go off to the side and factor that yourself. The denominator is kind of similar. An 8 factors out. Once you factor an 8 out, what's left is a difference of squares, y minus 1, y plus 1. And now that everything's all factored out, I can go crazy canceling, as long as I'm canceling something in a numerator and something in a denominator. I can't cancel across, only diagonal like this, or vertical, I guess. Across I have y plus 5s. The last thing to cancel would be the 12 and the 8 have something in common. 4 goes into 8 twice, 4 goes into 12 3 times. But I think that's all that can cancel, so I'll multiply what's left over. This 3 times this 3 make 9, and there's a y minus 5 left on the top. On the bottom I have a 5 times a 2 that makes 10, and there's a y minus 1 left there. If you want to, you can distribute the 9 and the 10, but it's kind of unnecessary. You can if you want, but why do it if you don't have to, you know? So this one, the first thing I need to do is, since it's division, before I even try to factor, because I don't want to confuse myself, I'm going to rewrite the first one exactly the same. But now we're multiplying by the reciprocal of the second one. Remember, you flip the second one upside down and multiply. Now its old denominator is its numerator, and its old numerator is its denominator. Alright, so the leftmost numerator factors into t minus 2, t minus 2. And I mean, you could write that as t minus 2 squared, but kind of leaving them separate in these types of problems is easier because you can see what cancels. The denominator, since it has a number in front of t, you're going to have to do that same method, that diagram method. So I'll go off to the side and try to factor that. Let's see. 3. Okay, we need a 3 and a 3. Oh, sorry, 3 and a 2, a negative and a negative. Negative 4. Yeah, okay, that's that one. The rightmost numerator is similar. You need to do that diagram method to factor it. So I'd probably go off and use some scratch paper to do that. So what are we going to need here? 5 and 3, 3 and 5. Okay, I think we need minus 3 plus 5. 10. Yeah, okay. On the bottom, that factors. That's a simple factoring method. Well, it multiplies to 25 but adds up to 10. It'd be 5 and 5. Alright, now I can start trying to cancel stuff. The first thing I saw was t plus 5's cancel. At least one of the ones on the bottom cancels with the top one. T minus 2's cancel here, and then on the diagonal, 2t minus 3's cancel. So on the numerator, all that's left is one of the t minus 2's, and the denominator, one of the t plus 5's. So it's all about factoring. I think if you're good at factoring, these problems are very easy. But if you're not good at factoring, they're very difficult. So definitely, if you work on factoring, you'll be fine for these problems. This one looks a little scary, but just remember, Even though the second expression is not a fraction or a rational expression, you can easily make it one. Remember, you can make anything a fraction by putting it over 1. Now that it's over 1, we know how to flip it and multiply. Because since it's division, just like the last one, we're going to have to flip the second one upside down and multiply, keeping the first one the same. So now a 1's on the top, and that 4z squared minus z minus 3 is on the bottom. And the numerator of the left guy factors into z minus 1, z minus 1. It's the easy factoring technique, what multiplies to 1 but adds up to negative 2. The denominator is difference of squares. The numerator on the right, there's not much you can do with 1, so I'll just leave him. This denominator, you have to use that diagram method again. Let's see. 3, it'll be plus 3 minus 1, right? Yeah, that's the guy. Okay, so what cancels? I think I see some z minus 1s above each other. There's another z minus 1 across the diagonal that'll cancel. So in the numerator, there's nothing left except that 1. In the denominator, we have z plus 1 and 4z plus 3. You know, and if you're left with two factors next to each other, I wouldn't bother multiplying them out. It's not really useful in any way. Okay, so that's that. What else? Now the next problem, now we got the next section. And this will be the last section we're tested on. Well, anyway, at this point, notice these guys have the same denominator. If they had different denominators, I'd have to find a LCD and yada yada yada. But at this point I don't. They already have the same denominator, x squared minus 4x plus 3. So all I have to do is combine their numerators. The first one was x minus 5, the second one was positive 2. And they have like terms, negative 5 and 2 makes negative 3. This is what we're working with. We've added, but now we have to see if it reduces. But remember, you can't cancel until you factor. The numerator can't factor, it's too simple, but maybe the denominator can. That's a simple factoring technique, what multiplies to 3 but adds up to negative 4, negative 3 and negative 1. Okay, and that way the numerator is one big factor. X minus 3 and x minus 3 cancel. But be careful, the answer is not just x minus 1. Since it's in the denominator, you have to put 1 over that thing. So if the only factor left is in the denominator, it has to stay in the denominator. Your answer will not just be x minus 1. And we're going to do something similar for the second one here. We've got, basically since they have the same denominator, I'm just going to put the numerators together. D squared minus 2d, really, is what we have going on in the numerator. Their denominators are exactly the same, so I'll just write it. And now I'll try to factor to see if I can reduce. The numerator, the two terms have a d in common. If I factor d out, d minus 2 is left. In the denominator, you're going to have to use that diagram method since there's a number in front of d squared. Let's see. I have to do minus 2 plus 1. Yeah. Alright. Now I see they do have something in common, d minus 2. So left over on the top was d, and on the bottom is 3d plus 1. There we go. Alright. Here we are. This one looks scary, but notice all three fractions have the same denominator. So I'm just going to go ahead and say, okay, 4x squared minus y squared. That's their common denominator. But the only thing is I got to be really careful here. Whereas in the last one, that minus sign between the two, it only went to one term here. Notice this minus sign is meant for this entire numerator. So I might be really careful when I combine numerators and write things in parentheses. So the first numerator was this, and I'm subtracting the second numerator, but since it has multiple terms, I'm going to have to put it in parentheses, because that minus sign was meant for both of these terms, not just the first one. And then you don't have to, but just to be safe, I'm going to do that same thing for the the third fraction. There's a plus, and then for that entire last numerator. There we go. So, okay, that 8x squared minus 3xy. Now I have to distribute this minus sign. It'll be negative 2x squared and then negative 5xy. And I guess I can think of it as I'm distributing this plus sign here, but what's that going to do? Plus 2y squared plus 2xy? You know, that doesn't do much, but really the thing to be careful of is this minus sign. If there's more than one term here, it has to be given to everybody there. Yeah. And then the denominator is just kind of waiting to see what happens with the numerator. So I got some like terms in the numerator, huh? I got 8x squared minus 2x squared. That makes 6x squared. And then I have negative 3xy minus 5xy makes negative 8xy. Oh, shoot, I forgot about this guy. Uh-oh. Sorry, I gotta erase that. Because you have three terms that are like. So negative 3xy minus 5xy makes negative 8xy. But negative 8xy plus 2xy makes negative 6xy. Wait, right? Negative 8 plus 2. Yeah. And there's only one y squared term, so he'll just be kind of on his own, poor little guy. Plus 2y squared. Okay. Let's see. So that guy. And then the denominator is the same. Whew! Now we're finally ready to factor. Okay. In the numerator, it's a trinomial. Actually, they have something in common, huh? I can factor a 2 out. What if a 2 comes out? X squared minus 3x. Oh, no. Sorry, 3x squared minus 3xy plus y squared would be left. Over 4x. Oh, no. And the denominator is a difference of squares. What's it called? 2x minus y, 2x plus y. Oh my gosh. I must have crazy brain. Okay, I just realized how, you're probably wondering the same thing. How did this xy become 2xy? Because I'm a ding-a-ling, as you already know by now. There should be no 2 there. And how would that affect it? Then the green things, negative 3xy minus 5xy would be negative 8xy. Negative 8 plus 1 would be negative 7. Alright, so this should be a negative 7 here. Sorry about that. Having a hard day, I guess. Oh my god. Alright, that means the 2 does not factor out. That's a bummer. We're going to have to do that crazy method, this one. This times this, and all that stuff. Okay, but if you do the long, diagram method, it's going to end up being 3x minus 2y times 2x plus, 2x minus y. And the denominator, I guess we kind of already talked about that. It's a difference of squares, 2x minus y, 2x plus y. Alright, and then I noticed these 2x minus y's cancel. So you're left with 3x minus 2y, 2x plus y. Whew! There it is. Sorry about that. I messed that up. Oh well. But let me know if you have any questions about these. These are kind of tricky, and if you were stuck on these last ones, it probably means that you need help with factoring. I would definitely practice more factoring. Go into the study guide section of my math lab and study those problems. Chapter 5 especially. Okay, thanks.